Chapter 4 Probability. Probability, which measures the likelihood that an event will occur, is an important part of statistics. It is the basic of inferential statistics, which will be introduced in later chapters. Combining probability and probability distribution, which will be discussed in the next chapter, with the descriptive statistics that you learned in the previous chapter, will help us make decisions about populations based on information obtained from samples. This chapter presents the basic concept of probability only. So this is an introduction to probability before we proceed with chapter 5, 6, and 7. What is experiment, outcome, and sample space? Experiment is a process that when performed results is one and only one of many observations. These observations are called the outcomes of the experiment. The collection of all outcomes for an experiment is called a sample space. For example here, when you toss a coin once, so that is the experiment. The outcomes of the coin, whether a head or the tail, so the sample space denoted by S is written as S equal to head, tail. If you toss a coin twice, the outcome could be head for the first toss or tail for the first toss. And for the second toss, it could be head or tail. So the outcomes are H, HT, TH, and TT. Another example is if you take a test, your outcomes could be pass or fail. So the sample space is S equal to pass, fail. So this is the concept of experiment, outcomes, and sample space. The sample space for an experiment can also be illustrated by drawing either a Venn diagram or a tree diagram. A Venn diagram is a picture, a closed geometric shape such as rectangle, a square, or even a circle. For the event or experiment of tossing a coin once, this experiment has two possible outcomes, either a head or a tail. Consequently, the sample space is given by S equal to H, T. To draw a Venn diagram for this example, we draw a rectangle and mark 2 points inside this rectangle that represent the two outcomes, head and tail. The rectangle is labeled S because it represents the sample space. To draw a tree diagram, we draw two branches starting at the same point, one representing the head and the second representing the tail. The two final outcomes are listed at the end of the branch here, H and T. What if we toss a coin twice? This experiment can be split into two parts, the first toss and the second toss, as you can see at a tree diagram here. Suppose that the first time the coin is tossed, we obtain a head. Then on the second toss, we can still obtain a head or a tail. If the first toss you get the head, so the result could be HT, or if you get the tail for the first toss, it could be TH or TT. So the first toss, if you get H, head, the second toss could be head and tail. If the first toss tail, then the second toss could be head and tail. So the final outcomes are HH, HT, TH, and TT. Suppose now we randomly select two workers from a company and observe whether the worker selected each time is a man or a woman. Write all the outcomes for this experiment and then draw the Venn and tree diagrams for this experiment. Let us denote the selection of a man by M and a woman by W. Each selection from the workers of this company can result in one of the two outcomes, either the man or woman. The example is quite similar with the coin that you toss twice. So the first toss or the first selection, because now you do a selection from the worker, either a man or the woman. So the outcome could be man for the first selection. And for the second selection, the outcome could be the man and woman. If the first selection you get a woman, the second selection could be the man and woman. So the final outcomes are 4. MM, MW, WM, and WW. So in a Venn diagram, there are 4 final outcomes and the sample space is written as follows.